Hi guys, so
Hello,
I'm Emma,
I'm Michelle.
and today we're going to be talking to you about learning microsystems through problem solving, guiding you through a little bit of challenge
Mhm.
problems and some MEMS components.
Yes.
And we are super excited for this, so let's get right into it with an introduction for you guys. So first we're going to start with MEMS applications. Micro electromechanical systems, that's what MEMS stands for. And they are very small devices or groups of devices that integrate both mechanical and electrical components. MEMS can be constructed on one chip that contains one or more microcomponents and the electrical circuitry for inputs and outputs of the components. The microcomponents include different types of sensors, transducers, actuators, electronics, and structures. Think gears, sliding mirrors, or diaphragms. Each type of component is designed to integrate with an input, such as electrical, like voltage and current, gas, like vapor, aerosols, and molecules, liquid, think inks, biofluids, or chemical solutions, radiation, like visible light, infrared, and X radiation, and other environmental factors and other environmental inputs like temperature and stress. MEMS can consist of a combination of devices in various scales. Think nano, which is 1 nanometer to 100 nanometers, micro, which is 100 nanometers to 100 micrometers, and macro, anything greater than 100 micrometers. And remember, when thinking about these applications, MEMS are used in everyday, day-to-day life. You can think of airbags or different devices that have to do with biomedical uses. Think blood pressure, measuring tools for blood pressure.
MEMS are fabricated using the micromachining process. The three most commonly used are bulk, surface, and Liga, which are short for lithography, galvanoforming, agforming. Bulk micromachining is a process that selectively etches into the bulk of a substrate to form a specific shape or structure. The sculpture in Mount Rushmore and ancient Indian cliff dwellings are examples of bulk processing. Bulk micromachining utilizes the crystalline structure of a crystalline silicon substrate by etching along specific planes of the crystal, and producing shapes such as mesas, sharp points, fluidic channels, and chambers. Surface micromachining is a process that forms components and structures by depositing, patterning, and etching a series of thin film layers upon a substrate. Typically, a crystalline silicon wafer serves as the substrate. Surface micromachining utilizes many of the same processes and techniques of semiconductor manufacturing, such as deposition of thin layer materials, patterning through lithography or photolithography, removal of material through a wet and dry etch, and the cleaning of the etched pattern. These series of steps may be used for each layer deposited on a substrate.